Just 1 second. So guys, anyone practiced price predictions completed? Anybody's done this time series? You're not done? Okay, leave it. Don't work that. Leave it. Ignore that. Just 1 second. In order to see this, okay, good. So I hope we understand, guys, what is meant by logistic regressions, why we call as a classifications, why not regressions. Yes, online guys. Avinav, I hope you clear. Yes, buddy. Tejasvi, all of them, Archana. Okay, so let me complete this classifications. I don't want to complete very fast, just slow down and then we explain. And today, if time allows, I talk about what is some overfitting, underfitting, how to check all those things practically. I'll show you. But let's see, what is confusion matrix, guys? I think you know about the confusion matrix, right? I just wanted to forget to tell you about sensitivity and specificity. So anyway, I'll talk about this later. But before that, I'm just wanted to explain the math concepts behind what exactly the logistic regressions, how exactly it works, all those things I'm gonna share with you this one. So let's do this. Okay. Just 1 second. Listen to me very carefully, guys. All right. And then we discuss this one. Okay. So why we call classifications? Why we call classifications, everyone? Because if we add the outlier, so the data has been skewed to between 0 and 1, isn't it? Between 0 and 1. Now, logistic regressions. Assume that, okay. So I have few data points here. So this is which color? Blue color. And this is red color data points. Understand? This is blue color data points. This is red color data points, right? Now, the first step, considered this is the linear regressions line. What is the equation of the line? Y equal to mx plus c. Many people write in different way. Y equal to wx plus b, or y equal to, even though the trigon theta plus theta, multiple b0 plus b1x, wx plus b, many people written on different way, guys. Understand? So those the equation is all about. Now let's understand. The blue color point means positive. Positive means what, guys? Greater than 0 means positive 1. Understand? So the red color point is negative. Negative means minus 1. All right. So Kirtan, are you listening me? Okay. So now here, so positive blue color point means positive plus 1. Red color means negative 1. I'll ask one question. If the line is touched to the origin, what happened, guys? Which one is 0? C would be 0. So can I say y equal to wx plus b, y equal to wx plus 0 is equals to wx. Understand or not? Yeah. So now here, we understand one side of the plane is positive, other side of the plane is negative part. Now let's talk about the case study 1. So here, let's assume I take one data point. Let's do this. This one. For example, I'll talk about this one. So here, if this is negative 1 means, okay, the distance is what? Negative 1 or not, guys? The weight also, if I go in this direction, so this is also negative. For example, There's two use case I'm going to explain you. The case one, let's talk about this point. Okay, let's talk about this point. This blue point is positive or not? Blue point is positive. So xi is positive. So if I going towards this directions, the point is positive, the distance also positive or not? So w positive and x also positive, agree? And y also positive, +1, because, so can I write the equations y equal to +1, w into x also greater than 0? On this case, can I write these equations y into wx is greater than 0? Guys, are you understand or not? Can I write these equations or not, online team? Yes, guys. So we can write these equations because y is positive, w and x both greater than 0. So I can write the equations y into wx also greater than 0. Understand? This is the case one. So greater than 0 means proper classifications happened. Understand? Now let's go back to the another case study. So if one point is positive, this point also greater than 0 or not? Okay, see, let me tell you, this data point is positive greater than 0 means rest of them is greater than 0. Yes or not, guys? Yeah, it's quite straightforward. Now let's go back to the case study 2. Case study 2. In the case 2, the red point is what? Negative, -1. W into x. W is positive. Let me tell you, this is positive. Wait, I mean, W coefficient will always be constant. It won't be changed. But the distance is negative or not? Yes, guys. So here, what exactly happened? Y is negative and Wx is also negative. So when I combine Y into Wx, greater than 0 or not, guys? See, because Y is -1 and Wx also negative. So negative into negative is what, guys? Positive. So in both cases, I will satisfy my condition is y into wx. If it is greater than 0, then my data points are properly classified. Team, are you understand or not? So if y and wx is greater than 0, then the data points are properly classified. I hope you understand. Right. Now assume, did you see, guys, there is a data point here which is red color. There is a data point which is here which is red color. Now what exactly happened? So y is positive and this is negative. What happened? Y into wx is not greater than 0. Not greater than 0. That means what happened? Misclassifications happen. Understand, guys? What exactly happened? Misclassifications happen. The same goes here as well. The same goes here as well. Understand or not? So can I maximize this? Y into wx is always greater than 0. Can I maximize this? Yeah. So I mean, what exactly mean by maximize? So let's go for this one. So that's why I can write the equations. I can create the equation is maximize all the data points, right? So let's say I have 10 data points. I need to get the most positive part toward y into wx. So here, that's what I create equations, maximize of summation of n, I equal to 1 yi into wx. Everybody understand this equation or not? Everybody's understand this equations, guys? This is the first part of math explanations behind. The moment when you write down from sklearn linear regressions, okay, linear reg model import logistic regressions, these formula is called in the backend. Understand, guys? These formula is called in the backend. Now let's talk about this one. This is the first part of explanations. I hope you understand. Now I'll tell you another example. Second part. The second part is, on this case, what happened? Regressions line can classify the data, isn't it? Regressions line can classify the data. But now let's check this one. On this part, did you see this is my regressions line? Can I classify the data or not? Yes. But I can prove you because of this outlier, this is not a classified. Let me show you. We understand this is the formula right now. Agree or not? We understand this is the formula right now. We got it. Now assume y equal to +1. Okay, means from the plane, the black color points is positive value, the blue is negative. So the distance between plane to the points is 2, 2, 2, 2, 2. All right. This is one side plane is positive, other plane is negative. And assume this is an outlier, which is 500 distance, right? Now let's see how to calculate this one. Y into Wx. So 2 into 1, y is what, guys? 1. 2 into 1, 2 plus 2 plus 2 plus 2 plus 2 plus 2. You get this? Now this part, -2 into -1 plus 2, -2 into -1 plus 2, and here goes on minus, outlier is 500 or not, guys? Outlier is 500. When I solve this, what happened? -480. -480 is what, guys? Y into Wx greater than 0 or less than 0, guys? Less than 0. So even though this line is properly classified, but due to outlier, it's saying this is a not classified, guys. I hope you understand. So that is the reason I wanted to add a functions over here. And this is the functions, and this function is called sigmoid functions. What exactly the sigmoid functions formula? Finally, I can say that, let me explain you. Sigmoid functions. Did you see, guys? Max of functions, and you apply y into Wx. So what exactly happened? This functions, when you apply, this is a probability functions. Your outlier has skew between the S curve. The outlier has skew between S curve. Understand, guys? So logistic regressions also called as logit. So this is what the sigmoid functions, at least you understand how exactly. Finally, I got to know the equation is 1 by 1 plus e to the power -1. This is what the sigmoid curve equations, guys. Yeah, 1 by 1 plus e to the power -x. Everybody's clear? Little bit math about. So this is all linear algebra or not? So that's why everybody say that you need to understand linear algebra. But these are very straightforward and simple explanations, guys. So what is the sigmoid curve range from? -1 or 0 to 1? Just one moment. Test. Checked it? 0 to 1. Yeah, it's a graph. Yeah. No, -1 to 1, other one, guys. We have other activation functions. Yeah. So I hope you understand sigmoid curve ranges from 0 to 1. I hope everybody's clear, guys. So the logistic regressions is also called that logit. Okay, classifications. Okay, in this logit, we understand this is probability part, and you know the sigmoid. Okay, this is also used for image data sets. All right, and it will work in neural network as well. Largely at output layer, we use what exactly we called as, we use this one, sigmoid activation functions. Okay, so this is all connections with -1 to 1 correlations. That's correct. No, -1 to 1 is their correlations, and also tan H activation functions ranges from -1 to 1. Okay, all those things I'll share you. I'll share with you guys. So let's work. I hope this is the little bit part I just explained you. Now let me go back to the practical part now. And there's a lot of things I wanted to talk about in this practical, guys. Okay, let me tell you, you're gonna get a lot of things. Finally, I just wanted to have some slides. Let me show you here. What is regressions? Regressions is a predictive modeling techniques. It estimates the relationship between dependent and independent variable. Clear? Next slide. Logistic regressions, what and why? it produced the results in binary format, which is used to predict the outcome of categorical dependent variable. So the outcome should be discrete and categorical, such as 0 or 1, yes or no, true or false, high and low, isn't it? Everybody's clear? So why not linear regressions? Since the value clip between 0 to 1. So that's why this is a not a linear, we got a sigmoid curve. Understand? Yes, guys? This is what exactly all about. Now the formulas, equations of a straight line in logistic and formulas, the equation is derived from the straight line equations. Okay. And finally, I compared this one, continuous variable, categorical or binary variable, right? It solved regressions problem. It solved classifications. We got straight line. We got sigmoid curve. Crystal clear, guys? We know the concepts. We know the math equations. We know the formula. So that's the way my few students, they mention the formula sheets. I will show you this one. And when the times allows, I will share with you all the details, guys. Yeah. Just one moment here. Just give me a second. Oops, I don't have this one here. Do you need this formula sheet or not, guys? I think it's opening. Just give me. Is it opened? Yeah. Opened 2 times, man. See, this is the formula, guys. So machine learning, calm down, wait. Regularizations, you know this? Loss, ridge regulations. Now you understand or not? What happened, Sharvani? Okay, so here, this is confusion matrix. Understand? Error rate, precision, recall, understood or not? Everyone. So elastic net regularizations, lasso regularizations, everything is logistic regressions. Sigmoid functions, p equal to p by 1 plus e to the power minus y. Log p by minus 1 sigmoid curve. Functions and curve, let me tell you, see the difference. And then maximize the values. This is what the maximize value. Clear, everyone? So why these equations, guys? This is all, I mean, many people explain different way, but this is the best way to understand all those things. Clear? Okay, now let's go back. In this lady, she mentioned very nice way. I'll share both of one. Okay, I'll share both of the things. Now let's go back for practical sessions. And in the practical sessions, I will explain different things, and you have to predict the future. I don't help you. I will tell you how to predict the future, and you have to build the work today. Everyone have to update your work. All right. So let me open this one. And I think I already opened this one. Oops. Let's close it. So here, logistic regressions code. Okay. Now let me go back to this one. So how to find use logistic regressions? How to find we use logistic regressions? Rihan, I'll show you whenever the dependent variable is binary. Okay, Rihan, you implement logistic regressions, support vector regressions, every model you can build. Understand? You can build every model. So that's what, oops, that's what I'm saying. If the dependent variable is binary, it's a blindly, it is an classifications. So the classifications means the first part we need to implement, which is called logistic regressions. Now let's understand this one. Let's look at this, guys. In this case, user ID, gender, age, salary, and purchase the car or not. It's a classify. What is dependent? What is independent variable? Purchase is dependent variable, and which one is independent? Rest of them are independent. Yes, user ID, gender, age, and salary of the independent variable. And I have purchase is dependent, right, Nishu? Yeah. So okay, which algorithm we're going to implement on this case? Classification algorithm. So the classifications, we understand the logistic part. So user ID does not decide whether a person purchased the car or not, isn't it, guys? And for me, even though, let me build this one. So now let me change, copy this, and okay. So can you do practical code line by line? Yes, of course. Every time I'm doing that only, right, buddy? Import NumPy, Matplotlib, Pandas. You know this. You know this, Rihan. So let me run this one. Understand? Now the data set is save this locations. By the time you guys very aware of all the small things, right? So let me copy the file, and this is what the data set I extracted from my file. Understand or not? This is the data set which we're discussing. Now, which is dependent variable, everyone? Which is dependent? Purchased. So if I remove this purchased variable, this would be my independent variable. Understand? Yes or not, guys? Oh, he's there. Okay, okay, yeah. So let's clear this one. And if I remove this part, this would be dependent variable. Rihanna, you understand now? Yes, buddy? Yeah, you tell me which one you practice first. Let's close this. Let's close this. Now let me split the data. Okay, independent variable data set. This is the data set hold entire data frame dot ilog. Okay, this slicing, you know this means it's starting from beginning to end. And I don't want, let me click this one, print the value, from second to third. Oops, just 1 second. Okay, see, I don't need, this is what the data set, right? Now, do you think female cannot buy the car? No, right, guys? So I can remove all the 2 attributes. So I can remove the 2 attributes, user ID and gender. 2 attributes are removed from here, isn't it? Now I have age and salary part. Understand, guys? I have age and salary part over here. So let's close this. Let's close this one. What is y now? Y is dependent variable. -1. Do you remember we practiced this -1 backward indexing, forward indexing? So same data set we split into 2 part, independent and dependent variable. So that's why, guys, if you remember the class notes, every time I'm just sharing with a lot of the required details and step-by-step approach already I covered. Yes, guys? Yeah. So please check this one, this part. Okay. What is import? What is feature scaling? Lot of things I want you to please review, and you can prepare your own documents, guys. This is a rough documents. Okay. So I make it based on you and my understanding. I want you to open this one and write it down what you learn on day basis. So this is the good way to practice. Okay. Now the next part is what exactly I'm going to do. I have to split the data. Yeah, I have to split the data. For split the data, I'll call the package train test split. Understand? I call the package train test split. Let's done this. And then at this moment, I wanted to make the test size 25%. Means out of 400 records, what could be the 25%, guys? Out of 400 records, yeah, 100 records. So 300 records are used for, let me tell you, Rihan, are you, so can you do practical? Yeah, so I'm doing line by line. Already we did many time back. Rihan, this is already done. So I want you to go back to the recording sessions and you understand. Yeah. So here, sklearn is what? Framework. Dot model selections, I'm calling train test split package. Yeah. In machine learning, first day only, I'm telling you what is xtrain, what is xtest, isn't it, guys? So let me execute this one. And after that, I create a variable for xtrain, xtest, ytrain, ytest, and I call this train test split. And x means what? Independent. Y means dependent variable. Test size is 0.25. and random state equals to 0. I will tell you today what is meant by random state. Let me execute this one. So what happened, guys? Did you check this part? Did you check this part? So in this case, data set contains 400 rows, 5 columns, right? But now independent variable and dependent variable, right? X test, X train, X test 100 records, X train 300 records. Guys, understand or not? Rihan, are you clear, buddy, now? Yeah. Let's go back to this one. What is normalization techniques, guys? I'm sorry, what is scaling techniques? What is scaling techniques? Standard scalar and normalizations. Normalizations and standardizations. Washim, understand? Surya Prakash? Avina, I hope it's clear for you. Nishu? Chandrahash? It's crystal clear, guys. Bitin, Drakshayani, Pavan, Chakri, everyone. Sinduri, I hope you can easily understand, right, Sinduri? Yeah. So here, from sklearn.preprocessing, all credit goes to sklearn, scikit-learn, right? sklearn.preprocessing import standard scalar. Can you tell me which one I need to make a scaling? Because if I open the xtrain and xtest, the student's age is not equal to the salary, isn't it? I mean, student age is 2-digit, but the salary is 5-digit, guys. Because machines does not understand 44 is never equal to 39,000. So I need to make a scale it. Scale means 44 has to bring down to 0 to 1 and 39,000 has to be bring down to from, I mean, same 0 to 1. So this is called scaling, guys. Okay. Standard scaling always gives you the standard deviations part. Understand? Normalizations always give you the scaling part between 0 and 1. So let's close this. Now I copy this, I create a variable called SC standard scalar. So let me execute this one. And SC dot fit transform xtrain. The moment when I do this fit and transform, let me check this one. What happened, guys? The 44 has the 19 has changed to 0.58 and 19,000 has changed to minus 0.88. Now, don't you think so, guys? There is a no difference between these two attributes. Everybody's understand? No, Avinav, this is not 0 to 1. It is a standard scalar. It will give you standard deviations. Avinav, clear? If I apply normalizations, then I will get 0 to 1. So here, if you scroll down, lot of the records does not find 1. If you check out some of them, 2.16. Got it? Yeah. So it will give you the standard deviations part. So I hope you guys are clear. So let's close this. And the second one is xtest, sc.transform xtest. Let's do this. It have been changed or not now? So do you want me to scale to this one? Why? White train, white test. Do you want me to scale? Required or not required, guys? Not required because it's already in the scale, right? It's already in the scale 0 and 1 because systems understand 0 and 1. So it's not required. Clear up to this? Up to this, everybody's clear, guys? Now the next step is, just one moment. So let's do this. Now the next step is, let's talk about this one also. Let me remove. Let's talk about logistic regressions. Okay. Now, before I build the logistic regressions model, first, yeah, I'll tell you random state. Let's complete. So let's click this logistic regressions. Let me click here. Not grid search, logistic. Penalty means what, guys? What is meant by L2? What is meant by L2? Online team. Lasso ridge. Penalty is L2. So here, see, logistic regressions also called as logit and max end. Okay. So the one who's studying IIT, guys, or in US, UK, you call them if you have any friends. Have you ever built max end classifier? He said, no, I never listened this. right? In school, colleges, they didn't teach me. Then you explain this. Did you check, buddy? This is maxent. Team, are you understand or not? Team, are you understand or not, guys? What exactly I'm saying? So understand this parameter is understand machine learning model. Very simple. Okay, guys. So that's why my students got the offers and they can survive as well. So now here, solver LBFGS, max iteration is 100, warm start false, and rest of things not required. But the main important, if you scroll down, L2 is lasso? No. L1 is lasso. Let's scroll down. Parameters. L1, L2 elastic net. Default is L2. Add L2 penalty term, penalty. Remember, guys, I told you the equations. I hope you understand whatever I'm explaining you. You guys are connected to the parameters. Agree or not? Yeah. So if you don't know all the penalty and parameter terms, you never build these models, guys. Yeah. Now, some penalty may not work with some solver. What is meant by solver? Let's go to the solver. Let's scroll down. So this is an algorithms. Newton, CEZ, LBFGS, LibLinear, SAG, and Sega. So the by default is LBFGS. All right. Which one should not use? For small data set, LibLinear is good choice. Understand or not? Okay. So these are the kernel. I mean, these are the parameters we need to implement while we build the models. Clear, guys? So it's clearly given indications for small data sets, liblinear is good choice, right? For multi-class problems, only Newton CZ. So is this a binary class and multi-class team? Binary or multi-class? This is binary. So for binary, we do not use 1, 2, 3, and all those things. And LBFGS handle multinomial loss, not multi-class, multinomial, isn't it? So liblinear is limited. I hope you understand, guys, what exactly? When I use Newton, I used this penalty. When I use LBFGS, I use this penalty. When I use this one, I can use both L1 or L2, isn't it? When I use SAG, I use this 2 penalty. But when I use this one, I'm going to use this one. So when I use LBFGS, what win? L2. So what happen if I use L1? Let's check. What happen if I use L1? But before that, let's build the model first. Before that, let's build the model. Understand, guys, what exactly logistic regression is all about? Understand? So now from sklearn.linear model, check this out. So let me write down here. So logistic, also called as logit and maxint classifier. Remember this one. Understood? Yes, guys. So that's what I've been written here. And if I go back to here, so just all right. And from sklearn.linear model, we can import linear regressions. Come on. And linear regressions and simple linear regressions. I'm sorry, I don't want to type bigger one here. SLR, MLR, logistic as well. Understand, guys? Logistic as well from linear model, even though logistic is a classifications, but we're going to import it from linear model because my regressions line also classify the data without outlier. Team, understand or not what exactly I'm saying? So here, the same way, let's build this one. Let's execute this part. And I create a classifier. Means what, guys? This, whatever the functionalities of the logistic regressions, means these parameters, okay, I call these parameters from a sklearn.linear model. Understand? So whatever the algorithms I call logistic regressions, I create a classifier to hold these algorithms. Understand? To hold these algorithms. And how to build the model? Dot fit this algorithms, please fit into my X train and Y train. Understand, guys? Fit into the X train and Y train. So what I'm going to do right now, let's go back X train and Y train. Let me fit this. Oops. 1 second. Execute, classifier, logistic regressions. Now I fit the model. When I fit the model, did you see the logistic regression is built? Now, what exactly I need to do? I need to check how my model is accurate, isn't it? So let's go back to do this. I create a Y pred and I pass X tests. See guys, there's a 4 tests we have. X train, X test, Y train, Y test. We build the model with X train, Y train. Yeah. And I pass the X test to the model. Model is generate Y pred. And I compare Y test with Y pred. Understand? This is what we discussed, isn't it? Now let's go back and pass this one. Let me execute. So now I compare Y test and I compare Y pred. Let me scroll down here. Good predictions. Customer does not buy a car from 0 to 6, but 7 customer buy the car, but my model also predicted 1. Yes. But if I scroll down where the line number 9, customer does not purchase car, but my model predict misclassifications happened or not? Misclassifications happened here, right guys? Everyone, misclassifications happened here. Now, whatever the model I build, what is the accuracy? What we build, we need to build this one. Yeah, what we need to build this one, guys. Confusion matrix from sklearn dot matrices import confusion matrix. Understand, guys? From sklearn dot matrices import confusion matrix. What is the matrix spelling? Yeah, matrix. Yeah, import confusion matrix. Now let's CM use for confusion matrix, and I'm gonna use this one. Copy, and I pass Y test, comma. What we need to build? Y pred. Okay. Now let's CM. So let's build this. Sklearn dot matrices. Matrix. I'm sorry. Now let's check this out. We got this. Yes, guys. Now I wanted to ask everyone. Let me go back to this one. What we got. So here's 65. What is the confusion matrix we got? Just one moment. 65 and 3, 8, 24, right? 65, 3 and 8 or 18? 18. 8, yeah? So 8 and 24. Can you tell me, guys, what is TP here? What is TN? What is FP? What is FN? Anyone tell me? 65 or 65, 3, 8, 24. Online team, can you tell me what is true positive? True positive, what is the value? 65, very good. What is true negative? What is true negative? True negative. 24. It's diagonal. That's okay. No problem. Okay. So you can put it as a C. I hope yesterday I told you this one, right? Subhashmita, I told it's this one. Online team, can you listen to me? So I think I was talk about in confusion matrix, this part. Just one moment. I was talk about true positive, true negative, false and false positive. Yeah. It's okay. It's TN also you can count it, but this diagonal is very important. Understand? The diagonal is important. Understand, guys? So listen to me. Listen to me this. Where is that? Just 1 second. Let's clear all these things and close it. And okay, tell me guys, what is FP? What is FP? 3. What is FN? FN? 8. Diagonal. Guys, are you understand? Diagonal, right? So now let's talk about this one. Let's talk about this one. What is type 1 error and what is type 2 error? 3. Shekhar, what is type 1? What is type 2? You forgot. So type 1 is, see, not works out, Shekhar, if this is the way. So this is type 1. All right. Sharvani, what is type 2 error? No, sir, I don't understand what you're speaking. Okay, I will listen recordings and get back to you. Yeah. Just what happened? Just 1 second, guys. Just 1 second. Okay. So type 2 is false negative. I know that, guys. In offline, only 4 people listening to me. Rest of them you just hear. Okay, it's not my wish, guys. Your choice. Again, I'm saying online is much better than you. All right. Everybody's here. But I'll tell you, only 4 people listen to my sessions. Rest of them, your body is present, your mind is absent. That's to be honest. Now your choice, guys. Okay, you say, sir, I didn't get a job. You never get a job, guys. You do not take this as a serious. To be honest, I'm saying. I show the offers, people are getting offers, and there's a hard time to understand and listen to what I'm speaking. Okay, so this is all type 2 error. Now, what is the model accuracy formula? So what is the testing data? Out of 400 records, what is the test data, guys? 100 records, right? Yeah, what are the training records? 300. Training records are 300 records. Online team, I hope everybody clear. Yes, Washim, very good. So now let's talk about how to build the model accuracy. 88%. So how do you calculate? So model accuracy equals to, what is the formula? TP plus TN divided by TP plus TN plus FP plus FN. Guys, every day I'm repeating the sessions. Okay, you are practicing, but in interview, you need to speak up, okay, before you get a job. Yeah, so TP plus TN. So what is the TP plus TN, guys? So TP plus TN means, look at this. This is called confusion matrix, guys. This is called confusion matrix. Okay, this is called confusion matrix. So in this confusion matrix, offline team, everyone, I will take one-on-one sessions, guys. Let's talk. Not right now, when the time comes up. All right. See, I need reach my goal actually if you study like this, to be honest. So TP plus TN means what? 65 plus 24 divided by 65 plus 3 plus 8 plus 24. So what is the percentages now? 89 percentages. What is my model predicts? 89% is my model accuracy. So I hope you understand online, guys. Chandra has understand. Now let's go back to check this out in the code. Let's see this. So here I can build from sklearn dot accuracy. Sorry. From sklearn dot metrics import accuracy underscore score. Okay. Enter AC is equals to accuracy underscore score. Then same y test and y pred. Y test. Let's copy this and I'm going to paste here. Now I call AC. Let's check this out. 89 percentages. Guys, are you understand or not? So what is the accuracy of my model? 89% I build the model today. What is the testing sample? What is the testing sample? Best. I can also increase it. I can also increase it. Avinav, let's do it. Now let me write down here. Let me write down here. Let me write down here. So 25% test data, all right, plus feature scaling, we done. We got the accuracy of 89 percentages. Same data set, 25% test data without feature scaling, accuracy, what will be, guys? It will increase or decrease? It will decrease. But let's see, we build the model, yeah? But before that, classifications report. So what is this classifications report, guys? Let's check this out. Let's check this out. In this classifications report, do you see precision, recall, F1 score? What is meant by F1 score? I didn't explain to you. So just one moment, let me explain this. Let me explain this. Just one moment. Just 1 second. I think I just little bit formula. Okay, I think my students mentioned this one. F1 score. The F1 score is, just check this out. So the F1 score formula is 2 into precision into recall. Okay, 2 into precision into recall divided by precision plus recall. Write down this, Subhasmita. Writing, yeah. So let me add this one. What is F1 score? F1 score equals to 2 into precision plus or into? 2 into precision into recall divided by precision plus recall. So when you calculate this one, you're going to get this as your output. Test accuracy, that's correct. This is all these things. I hope you understand, guys. So if you see this, 89% accuracy, precision is 92. Guys, are you understand or not? Everybody's clear what exactly I'm saying? Everybody's clear or not, guys? Team understood? So now the last part, tomorrow we'll see. I didn't have it yet. I have a lot of work on this one. Okay. If I explain one algorithm proper, I'll take 2 day, 3 day for this one, only practical. Rest of algorithms are easy for you guys. I'll check how to check overfitting or not. Does my model is overfitting or underfitting, guys? We need to check, right? So how to check this? Tomorrow we're going to discuss. But before that, tomorrow Saturday, wow. Is it, Nishu? Where you stay? May I know, please? Okay, tomorrow Friday. Okay, Nishu, no problem. Okay. We have session tomorrow, okay? Don't take leave. So here, okay, I'm sorry, it's time up. I will explain some of the points tomorrow. I hope everybody's clear, guys, this topic, yeah? So today, please complete the old task, and tomorrow I will complete a lot of things, random state and overfitting, underfitting, all of things, guys. All right? Yes, Nishu, understood or not? Understood or not? Okay, guys. Yeah. Yeah, thanks, guys. So see you tomorrow. So do we use feature scaling for all the regressions? Feature scaling not required, Sindhuri, as I told you. Okay. Yeah, no problem. Share updated projects, sir. I already shared on the class notes, Chandrahas. I will complete, then I will share for rest of things. Okay, Chandrahas. So whatever, did you complete the price prediction task? If not, then please complete and let me know. Okay. See you tomorrow. Don't miss sessions, guys. I'm in task. I'll share. I already shared, Chandrahas. You check this out. I mean, you can find out in class notes. Okay, you can find out in the class notes for predictions. I will share classification. I'll share tomorrow. Okay. Thank you so much. See you tomorrow. Okay. Bye, guys. Kirtana, you got visa interview done? 31st. All right. So you will clear? Okay. Bye, guys. But sir, feature scaling give quite good accuracy in some model. Pratyush, you done in the feature scaling for regressions, Pratyush? We'll speak tomorrow, Pratyush. Okay. Yeah, we'll speak tomorrow. Yes, then okay, no problem. Not all algorithms. I said 3 algorithms does not required. We'll see that in practical. Okay. Yeah. See, discuss tomorrow. Bye, guys. See you tomorrow. Have a good day. Yeah. Okay. See you tomorrow. Have a good day. Bye. Yeah.